So the other terminologies that we are going to use to derive that. So what we are going to do is, this is a very simple form. So we are going to use replace this mass by mass fractions. Okay, so that gives you a much more understanding on how to design an efficient rocket, or how to optimize the mass of the propellants, of the structural mass, of the payload mass. How do you optimize this thing? So for that we need to expand these mass into mass fractions. So let ml is the payload mass, m capital letter L is the payload mass, ms is the structural mass, and mp is the propellant mass. So the total mass of the rocket, or original mass of the rocket, is actually the sum of all these: payload mass, structural mass, propellant mass. As simple as that, ml plus ms plus mp. The total mass of the rocket after the burn time, after the propellant has been burned, what is the mass of the rocket? That indicates mp. That is nothing but the original mass minus mp. Original mass minus mass of the propellant. That is also equal to the structural mass plus the payload mass plus the structural mass. So initial mass minus propellant mass gives you mp, or you can say ml plus ms also. So mass ratios are, or mass fractions, mo by mb is actually, you can rewrite this mp as either ml plus ms or mo minus mp. That is indicated as mu. Okay, mu. Now in the text of Balachandran, actually you have another indication, like something like, I guess it's mi or something like that. He actually uses the reciprocal of this thing, m final divided by m initial. Okay, so he actually indicates the mass fraction, and in the text of Balachandran he actually uses a mass fraction like this, so you don't need to get confused. The only thing when you write the equation is delta V is equal to ISPGE ln m, instead of mo by me he write 1 by this mass fraction mi. Okay, so this is nothing but our mo by mp. Why I'm using this notation? Because in most of the textbooks other than Balachandran, especially in foreign textbooks, foreign authors prefer this kind of notation. So later on, if you want to refer to any other textbooks for deep information, this will be handy. Okay, this kind of notation. So your mass fraction mo by mb can be written this term, and I'm going to use mu to represent mo by mb. So that is mass fraction. Now the other two mass fractions are the payload ratio, lambda equals ml, the payload mass, divided by the propellant mass plus structural mass, or mo minus ml, the initial mass minus the payload mass, which will give you the propellant mass plus structural mass. Okay, so in plainly you can remember this as, okay, lambda is actually indicative of payload fraction or payload ratio, mass ratio. So this is nothing but payload mass divided by the propellant mass and the structural mass. Okay, other than the payload mass you have propellant and structural. Okay, you can remember like that. So usually lambda is less than 1 for launch vehicles. Lambda is greater than 1 for short range missiles. So in the purpose of military or missiles, the payload is actually maybe a bomb or something like that. So we have to consider that as a higher, greater than 1. In structural mass fraction, structural mass fraction is indicated as epsilon. Epsilon is equal to ms by ms plus mb. Okay, so both these are similar, lambda and epsilon. The only difference is in the numerator. Okay, in structural mass fraction you have ms, the structural mass, divided by the structural mass plus the propellant mass, whereas here payload mass by propellant mass plus structural mass. Okay, so the denominator part is the same thing. The final expression of delta without considering drag and gravity, if you plug in these values, your delta V can be rewritten in this form: and you can simplify into this form. I'm not going into the simplification, I'm just giving you the final answer. So ISPG ln in square brackets 1 plus lambda all divided by epsilon plus lambda. So what is the good thing of this equation? You get to find out the mass fractions if you this is particularly handy in the case of multi-stage calculations. So multi-stage calculations, if you know the mass fractions, it is very easy to find out the delta V.